Hello, statisticians. In section 7.2 Excel tips here, we're going to take a look at applications of the normal distribution. So now, very similar to the standard normal, but we're going to actually have some use for the probabilities in the real world using a slightly different command, now equals norm.dist, open a parentheses, x, which is the value we're interested in, comma, the mean of the distribution, comma, the standard deviation of the distribution, comma, true. That'll give us the area to the left of that x value on a normal distribution with the mean and standard deviation we type in. If we already know the probability and we want to know the x value that gives us that probability, we'll use equals norm.inv for inverse, open parentheses, the probability we want, comma, the mean, comma, the standard deviation. Again, both of these commands will only work to the left of the normal distribution. So if we ever need the right side, we're going to have to do a little bit of manipulating to make it work. Also, as we're solving these, it's going to help again to draw a picture every time to make sure I'm on the correct side of the normal distribution. So for this first example, the mean height we are told is 60 inches. That's our mu. And the standard deviation is 2.4 inches. That's our sigma. So we're going to find the probability that a random person is shorter than 63 inches. And so if I draw my normal distribution, the mean in the middle we said was 60. We want the probability of being less than 63 inches. Well, 63 is over here to the right. So we should expect this probability to be more than 50%. But because we're going shorter, we are on the left side, which is the way the distribution is set up. So we can type in equals norm.dist, open a parentheses, the x value we want is 63, comma, the mean of the distribution is 60, comma, the standard deviation is 2.4, comma, and then we're always going to finish with true. When we hit enter, we'll find out the probability of being to the left of 63, shorter than 63 inches, is 89.43%, or 0.8943. If we switch it and we actually want to be taller, so here we've got our mean of 60 in the middle, taller than 53, 53 is down here and we want to be taller. But that's the right side of the distribution. So again, just like we did with the standard normal, we're going to use the complement by saying equals 1 minus, and we'll subtract off the left side of 53 with norm.dist, open a parentheses, the x value is 53, the mean is 60, the standard deviation is 2.4, and then we always finish with true. Close the parentheses, and we find the probability of being taller than 53 inches for an individual is 0.9982. We can do between two values in a way that's very similar to what we did with the standard normal distribution, where we just subtract the two areas. Again, we've got a mean in the middle of 60, and we want to be between 56 and 61. We'll start with the bigger area, the 61, and we'll subtract off the white area that's to the left of 56. With equals norm.dist, open a parentheses, 61, comma, the mean is 60, the standard deviation is 2.4, and then we're always going to say true. But this time we're going to subtract off the tail that we don't want, everything to the left of the 56, which is norm.dist, open a parentheses, 56 is the value we want, the mean is 60, the standard deviation 2.4, and then always finish with true. And when I hit enter, we find out the area between those two values is 0.6137, or about 61% of people are going to be between 56 inches and 61 inches. Now for these last two, we're already going to have the area we want, and we need to know what is the x value that goes with it. So we've got a mean of 60 in the middle, and we want the height that is taller than 40% of people. So if we draw a line here and we've got 40% are the short people to the left, we want to know what x value, what height is taller than 40% of people. Because we already have the probability, this is going to be the inverse. So we'll say equals norm.inv for inverse, the probability we want to the left, which is 40%, comma, the mean we want is 60, comma, our standard deviation is 2.4, and close the parentheses. When we hit enter, we find out somebody who's 59.39 inches is taller than 40% of people, or in the 40th percentile. Contrast this with the height being shorter than 90% of people, with 60 in the middle. We want the spot where 90% of the people are taller than our person. So this x value has 90% of people taller than it, but you notice that's the right side. So we need to find how much area is in the left side so that we can use the normal distribution function in Excel. Well, if there's 90% to the right, we know there must be 10% to the left. If you're shorter than 90% of the people, you're taller than 10% of them. So we can say equals norm.inv for inverse, the probability of 0.10, comma, our mean of 60, comma, our standard deviation of 2.4, and close the parentheses. And we see that someone who is 56.92 inches is shorter than 90% of the people. Again, you'll notice this is very similar to the standard normal distribution of the prior video. It helps to draw a picture, and the commands only work to the left side. So if you want the right side or the middle, you might have to do a little manipulating to get what you want.